Hello everyone, welcome to Myadyapika. I am Ayush and I am a physics teacher here for entrance examinations, JEE, NEET and even school exams, which includes CBSE boards. Today in this live session, we will be covering a few questions of physics. There is a test paper on a few chapters in the beginning of Physics 11 standard, that is units and measurements and kinematics. And we'll be covering a few questions from that test paper in this particular session. Sorry about that. Okay. So let's start with the first question. Please have a look. The dimensions of angular velocity are. Very simple question of angular velocity. You know what angular velocity is if you have studied kinematics. Angular velocity is basically the rate at which the angle subtended changes. So let's say if this is a circle in which a particle is moving, and obviously it is covering certain angles like this as it moves from here to here. So the rate at which this angle subtended, when it's at this particular point, the angle subtended is this. When it's at this particular point, the angle subtended is this, and so on. So the rate at which the angle subtended is changing, that is nothing but your angular velocity. So just like your velocity is distance covered upon time, your angular velocity is angle covered upon time. So now that you know its angle covered upon time, what do you think its dimensions are? I'm gonna wait. Yep. Okay. So the answer for this question is going to be M0 L0 T minus 1. And why exactly is that? Because angle is a dimensionless quantity. As you know, you also know this equation, right? L is equal to R into theta. I'm sorry, this is theta into R. So you know the dimensions of R. R is radius, is length, and you know the dimensions of L, which is the arc covered, is also length. So both those dimensions are length. So the angle has to be dimensionless, right? So if you're talking about angular velocity, which is basically your angle theta upon time, then it's going to be dimensionless upon time. So it's going to be t minus 1, m0 l0 t minus 1. Okay, awesome. So I'm gonna move to the next question. A body starts from rest and travels with uniform angular uniform acceleration on a straight line. So here we're talking about a straight line motion. If its velocity after making a displacement of 32 meters is 8 meters per second, its acceleration is. So you have a body which is at rest right now. Rest means its initial velocity u is 0. Then it's traveling with uniform acceleration along a straight line. So it's as it's moving, let's say, like this along a straight line with an acceleration. Because of this acceleration, its velocity will start increasing. Initially, its velocity is 0, and obviously this acceleration is going to impart some velocity onto the particle, and its velocity will start increasing. right? So after its velocity starts increasing, they are asking that when it has made a displacement of 32 meters, its velocity is 8 meters per second. So after a distance s of 32 meters, it has made a velocity, it has come to a velocity 8 meters per second, which is basically your v. So this is your v and this is your s. Okay, your u is 0. So when you know v, you know u, and you know s, then how can you calculate the acceleration? Think of an equation. You know the three equations of motion. Think of that equation which relates s, v, u, and a. Okay. I'm going to move ahead. So there is going to be one equation which relates all these variables. It's v square minus u square is equal to 2as. So you know the equation v square minus u square is equal to 2as. So now if you know v is equal to 8, so 8 square is 64, minus u square is 0, is equal to 2 into acceleration 2a into s. S is what? 32 meters. 32, right? So if this is the case, then can you not easily, very easily calculate your acceleration? You can, right? Here you have 64. Here you have 32 into 2, 64a. 64 gets cancelled and your answer becomes 1 meters per second. This is your answer. This one was a previous answer, right? Okay. So fairly easy question. In a lot of your kinematics questions in one dimension, all you have to do is you have to just think of the three equations that you have. V square minus u square equal to 2as, s is equal to ut plus half at square, and v is equal to u plus at. Think of these three equations based on what you are given in the question and what you have to calculate. Find out what is the most appropriate equation to be used, and then based on that, just put the values into that equation and calculate your answer. Okay, let's go to the next one. The displacement in meters of a body varies with time t in second as y is equal to t square minus t minus 2. The displacement is 0 for a positive t equal to. So what do you understand by this question? The displacement, which is, let's say, s, or here it's given as y, that is given according to a particular function of time t. Now, this is not really a uniform motion. It is straight line motion, but it's not a uniform motion. What do you mean by uniform motion? Uniform motion is one in which your acceleration is 0. Also, it is not a uniform acceleration motion. Why? Because if it was the case, then there would be some constant acceleration given to it. Okay, we might use this particular equation and find out that the acceleration comes out as constant. But this is another way of basically describing your motion by giving your distance as a position of time t. What this equation means is that when you put time t is equal to, let's say, 1 into this, it will become 1 square minus 1 minus 2, right? So that will become minus 2. Y is equal to minus 2. So at time t is equal to 0, when the time is starting, it is at a position of, let's say, minus 2 here. Then at time t is equal to, I'm sorry, this is t is equal to 0. Then if you put t is equal to 1, it again becomes minus 2. So from t is equal to 0 to t is equal to 1. So from the 0th second, when the time is beginning, to the first second, that is for the first 1 second, it is not moving at all. Why? Or is it moving? It is moving. Why? Because if you put, let's say t is equal to 0.5 here, then it's going to be 0.25, 0.5 square minus 0.5 minus 2. So it's going to be somewhere here, right? Because it's minus 2 minus some other quantity, because 0.25 minus 0.5 would become a negative quantity. So this particle will land up here, right? So it is moving. So at time t equal to 0, it must be here. It is moving somewhere here. And at time t equal to 1, it is coming back here, because when you put t is equal to 1 in this equation, it's still coming out as y equal to 0. Now you put the next second. Let's say if you put t is equal to 2 seconds. So 2 into 2 is 2 square is 4 minus 2 minus 2. So again 0. You put t is equal to 3 seconds. There's going to be a value. So basically you put different values of time t in this equation, and then you will find out the position. So this is how this equation can be interpreted. So they are saying, when is your displacement 0 for a positive t? So all you have to do is you have to equate this displacement to 0. So you have to put this thing equal to 0. That's it. And after that, I mean, whatever the value of t is your answer. Okay. So I mean, I'm sure some of you, I mean, most of you, all of you must have done your quadratic equations in your childhood. Just give me 1 minute. Sorry about that. So I'm sure you guys must have done quadratic equations in your childhood, and this is exactly it. You are going to solve this like a quadratic equation, t square minus t minus 2 equal to 0. So then if you factorize it, you can either do it using your formula minus b plus minus under root b square minus 4ac upon 2a. You can use that formula, or you can do it like a normal factorization method. But if you do that factorization, I'm not going to show you that factorization because it's something related to basic maths, and I'll expect you to know that. But once you do that, I'm sorry, this is going to become t minus 1 into t into t minus 1. I'm sorry. Let's t into t minus so you're going to break this down as minus 2t plus t. So t into t minus 1, sorry, minus 2t plus t. So t plus 1 into t minus 2. Okay. T plus 1 into t minus 2 is going to be your factorization. T plus 1. I'm sorry for this poor handwriting. Into t minus 2. Okay. So once I do that, you can recheck. You can just calculate it in your mind. This is going to become t square minus t minus 2 only. So this is the correct factorization. And this is equal to 0. Right? This particular thing is equal to 0. This is equal to 0. So when is this going to be 0? Either t is equal to minus 1 or t is equal to 2. Now t is equal to minus 1 is not possible because time cannot be negative. Time starts with 0 and always moves in the forward direction. It's not possible. So answer is going to be t is equal to 2. It's going to be B. Okay. Okay. Just give me 1 minute. Okay. So now let's go to the other question. Question number 4. Okay. A body makes a displacement of 4 meter due east from point O and then makes a displacement 3 meter due north. Its resultant displacement. Very simple question. 4 meters through east. So this is how it's moving. From west to east, it's moving 4 meters. And after doing that 4 meters, it makes a displacement of 3 meters due north. 3 meters north. So its resultant displacement is going to be this vector, right? Distance covered is going to be 4 plus 3, but displacement is going to be from initial position to final position. So you have to find out this. So from childhood, can you remember Pythagoras theorem? And in this formula, in this triangle, you can do under root of 4 square plus 3 square. If you do that, under root of 4 square plus 3 square, you will get it as 5, because 4 square is 16, 3 square is 9, 4 square plus 3 square is 25, and under root of 25 is 5. So automatically this side comes out as 5, and this is going to be your displacement. So your answer is C. Okay. Now, just give me 1 minute. Yeah. Now, let's look at the next one. This is a conceptual question. I hope you guys have read the chapter and you must be knowing. Absolute error of measurement is the difference between individual measurement and the true value of the quantity cubed, difference between individual measurement and true value of quantity squared, difference between two individual measurements and their mean, difference between two individual measurement and the true value of the quantity. I'm going to pause. Okay, well, this is a definition-based question, not much to be explained here. The answer for this question is A. Absolute error of measurement is difference between the individual measurement and the true value of the quantity cubed. Okay, not much to be explained here. Okay, in a system of units, if force F, acceleration A, and time T are taken as fundamental units, then the dimensional formula of energy, again, units and dimensions. Usually when you are working with units and dimensions, you take the three basic units, right? You take M, you take L, and you take T. And in terms of all of these, in terms of M, N, L, and T, you determine the dimensions of everything. Okay. Now that is not the case. You are no longer having M, L, and T as your basic dimensions. This is a very common type of question that you can encounter in NEET and JEE mains. Your M, L, and T are no longer the basic dimensions. Instead, something else is a basic dimension. F, A, and T. So see, if A is your basic dimension, basically, you know the dimensions of acceleration, right? Acceleration dimension is mlt minus 2 meter per second square. lt minus 2 meter per second square is lt minus 2. Force is mlt minus 2. Why? Because it's kg meter per second square. So mlt minus 2. Acceleration is lt minus 2. So these are your basic dimensions. You're no longer going to take force F as mlt minus 2. You're going to take it as F only. So in order to find out the dimensional formula of energy, you have to think, how can you relate energy with these three quantities: force, acceleration, and time? How can you relate energy with these? You have to think. So now, those of you who have a basic idea of further chapters like work, power, energy, you must be knowing that energy is nothing but energy stored as a result of work done. When you do a work on an object, not just work that we use in common English, the work that is defined as per the physics, when we do that, then then it's the energy, it's the work that is storing the energy. So the units of energy are going to be the same as the units of work done. And the units of work done can be easily, you know, found out using these things. So work done is what? Work done is force into displacement, correct? So you have already found out F here. You're anyways going to get F over here because it's force into displacement. Now you have to find out the unit of displacement. How do you find out the unit of displacement? Displacement, can you find out the unit of displacement from acceleration? Acceleration is speed, I mean delta V upon time, correct? And so, I mean, as per the units is basically L upon T square, correct? We just discussed LT minus 2 is the unit of acceleration. So the unit of acceleration is LT minus 2, and unit of displacement, if you look at the normal scenario, your the normal basic fundamental units, M, L, and T, your LT minus 2 is the dimension of acceleration, and your L is the dimension of distance or displacement. So LT minus 2 is your acceleration. So your unit of displacement, which is L, is nothing but A into T square, right? I mean, if you want to, you can either put acceleration in terms of displacement by LT minus 2, or you can do the reverse. You can find out displacement in terms of acceleration as AT square or AT2. So your displacement's unit is nothing but AT2 when it comes to acceleration and time as the fundamental units. Okay. So 82 into F. 82 is your distance or displacement unit. F is your force unit. So F82 is going to be your answer. F82. Okay, because force into displacement has to be the answer. Okay, let's move ahead. The path of a particle is given by the expression y is equal to 8 dt square, where a and b are constants. Y is the displacement at time t. Its velocity at any instant is given by. So it's very similar to one question that we have already done, in which we had given y is equal to t square minus t minus 1 or minus 2. We had given displacement as a function of time t. The only difference is here also we have a displacement as a function of time t, but it's not a fully defined function. There are some constants a and b that we do not know. Now you have to find out that what is the velocity at any given instant time t. So it's very easy. I'm sure you guys must have seen dy upon dt. Dy by dt is your nothing but velocity. Okay. And dv upon dt is nothing but acceleration. Okay. So dy upon dt is your velocity. You can do dy upon dt from here. If you differentiate this with respect to time, it's going to be a plus 2bt. Right? So a plus 2bt is going to be your answer. There's another equation that you guys must be knowing, dv upon, if you do dv upon dt, if you further differentiate this with respect to time and your answer comes out to be, let's say 2b, when you do dv upon dt, that's going to be nothing but your acceleration. Now, another thing that you can see here is because its acceleration is 2b and b is a constant, it's a constant acceleration motion. Constant acceleration motion means all your equations such as v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. All these things will become valid. Okay. Okay. I'm going to move to the next questions. The total flight requires a time that is, let's look at this, let's look at projectile motion now. When we are talking about flight, we're talking about projectile motion. You know projectile motion, right? This is how it goes. Let's say this is the ground. It's fired like this. It comes on the ground like this. Okay. So total flight requires a time that is, total flight is going to be the time required from going to here to here. And as you guys must be knowing, your projectile motion is a symmetric motion. So the time required to go from here to here, the topmost point or the middle point, is the same as the time required to go from here to here. Topmost point is the same as the middle point. Okay. So let's look at the options. 4 times the time necessary to reach the maximum height. No, because time needed to reach the maximum height is this much. So obviously the total time flight is going to be twice of that. Thrice the time necessary to reach the maximum height, again wrong. Equal to the time necessary to reach the maximum height, again wrong. Twice the time necessary to reach the maximum height, this is going to be the correct answer. Because time required to reach the maximum height is, let's say, this much, multiplied by 2. This is going to be the total time required to reach the end. Okay. All right. A body starts from rest and travels 40 seconds with uniform acceleration of 2 meters per second square. If the displacement made by it is 16 meters, time of travel is. So body is starting from rest and it's traveling for t seconds with uniform acceleration. So again, uniform acceleration means those 3 equations of motion are going to be valid. Displacement is 16 meters. So let's mark what all we have. This is 16 meters. This is going to be your S. This is 2 meters per second square. This is going to be your A. So you have, and it starts from rest. So you also know U is equal to 0. So you already know U, you already know A, and you already know S. So after this, how are you going to solve it? Think of an equation that relates all these things. So the equation that has U, S, and A is nothing but V square minus U square equal to S. No, well, you have to find out time, T. So you can use S is equal to UT plus half AT square. S 16 is equal to UT 0 into T 0 plus half into 2, half to T square. 2 gets cancelled. 16 is equal to T square. T is equal to 4 seconds. That is your answer. T is equal to 4 seconds. Very simple question. If it's uniform acceleration, you have to use one of those 3 equations that you already have. You just look at the question, find out what values you have, what quantities you know, and then whatever you don't know, that also you have to keep track. See, because if you know U, A, and S, you can also think of using V square minus U square equal to 2AS. But what's the point? That equation is going to give you V, right? But calculating V is not the objective here. You have to calculate T. T is asked in the question. So you have to relate T with V. You have to relate T with U, A, and S. That's going to happen through this equation. Okay. All right. Next question. A boy starts from point A, travels to point B at a distance of 3 kilometers from A, and returns to A. if he takes 2 hours to do so, his speed is, so let's say this is point A and this is point B. Okay, this is point A. Starts at point A, travels to point B at a distance of 3 kilometers. Returns to A. Okay. If he takes 2 hours to do so, his speed is, all right. All right. So if he takes 2 hours to do so, then what is going to be your total, like how do you describe a total journey? It's a total of 6 kilometers. Why? Because from A to B, it is traveling a distance of 3 kilometers and then it returns to A. So 3 plus 3, 6. And then 6 kilometers, it travels in 2 hours. So your average speed is going to be total distance covered, not displacement. If someone asks you average velocity, it's going to be 0. Why? Because your displacement is 0, right? After 2 hours, it's coming to the same point. But if someone asks you average speed is going to be total distance covered upon total time taken. So total distance is 6 and total time taken is 2 hours. This becomes 3. So your answer is 3 kilometers per hour. As you can see here, you have 0 as an option here. So people who get confused between speed and velocity are going to get it wrong. They're going to put 0, but that's not the case. They've asked you speed, not velocity. Okay, so it's going to be 3 kilometers per hour. Okay, let's move to the next question. The displacement in meters of a body varies with time t in seconds as y is equal to t square minus t minus 2. The velocity is 0 for a positive of t equal to. This equation looks fairly similar, right? We saw this equation a few questions back. I can scroll up as well. Here is the case. So displacement of in meters of the body varies with time t as this, right? And then they ask displacement is 0 for what time? So when you had to find out displacement equal to 0, all you had to do was you had to equate this to 0 and then you have to find out t corresponding to that. When we did that, we came up with two values. T is equal to -1 and t is equal to 2, if I remember correctly. And obviously -1 cannot be an answer because time has to be positive. And well, they have specifically mentioned also for a positive of t equal to. But even if they did not, you had to take positive only because time cannot be negative. Time only moves forward, right? So that was the displacement. But when someone is asking you about the velocity, what are you going to do? From displacement, how are you going to find out velocity? Fairly easy. We just covered ds, or let's say dy upon dt is equal to dy upon dt is equal to velocity, right? So if we did this in another question very recently, your dy upon dt is velocity, so dv upon dt is acceleration. Okay, so when you do that here, your dy upon dt is going to become 2t minus 1. So this is going to be your equation of velocity. So if this is your equation or your expression of displacement, this is your expression of velocity. You put any value of t here, you're going to get velocity. You put t is equal to 1, you will get 2 into 1 is 2 minus 1, 1. So you'll get v is equal to 1. V is equal to 1 meters per second at time t is equal to 1 second. If you put t is equal to 4 seconds, let's say, you put it here, 2 4s are 8 minus 1 7. So at 4 second, your velocity of the body is going to be 7 meters per second. Okay. So it's 7 meters per second. So this is how you use your equation. Now, if you have to find out velocity equal to 0, you equate this to 0. And when you equate this to 0, can you find out the time at which this particular equation is 0? It's very easy, right? 2t minus 1 is equal to 0. So t is equal to 0 0.5. 0 0.5. Okay, so at time t is equal to 0 0.5 or time t is equal to 1/2, your velocity becomes 0. Can you also find out what's the displacement at that time? You can put 0 0.5 here to find out the displacement. It's going to come out in negative. So when time t is equal to 1, it's somewhere at -2. At time t is equal to 0, it's again at -2. At time t equal to 0 0.5, it's somewhere left of -2. So basically it started moving like this, and after 0 0.5 it came back like this. So at 0 0.5 it was basically changing its direction of motion. Earlier it was moving like this, then this. So while changing, in the process of changing its direction of motion at this particular point, its velocity was 0 for that particular instant. Okay, awesome. Let's move to the next 12th question. A car is moving with a speed of 30 meters per second on a circular path of radius 500 meters. The speed is increasing at the rate of 2 meters per second square. The acceleration of the car is. We are talking about circular motion now, and you know that the speed of the car is 30 meters per second. Okay, so if this is the circle, at a particular point your speed is tangential, right? It keeps changing at every point, and at one particular point it's tangential. It's 30 meters per second. Now, on a circular path of radius 500 meters. So this is going to be 500 meters. The speed is increasing at a rate of 2 meters per second square. So the speed with which it is moving, it is increasing. So if you look at it in terms of straight line motion, the speed is also increasing. Okay, it is already moving in circular path. It is already moving like this, and you know that when a object is moving in circular path, there is an acceleration associated with it, which is centripetal acceleration. It is the centripetal acceleration which is enabling it to move into circular direction. You already know that, right? So when it is moving in that circular path, then there is an acceleration, centripetal acceleration, which is towards the center. And then because the speed itself is increasing, there's an acceleration in the tangential direction as well, like this. So there are two accelerations that are acting on the car. One is towards the center, which is centripetal acceleration, and one is towards the tangent, which is tangential acceleration. Centripetal acceleration is compulsory because it's moving in a circle. It has to be there. And tangential acceleration is there in this case because they have specifically mentioned that your speed is increasing at the rate of 2 meters per second square. So now if you know two accelerations of a car, let's say there is a car here and it has two accelerations. One is like this and one is like this. How are you going to find out the net resultant acceleration? Because when they have asked you the acceleration of the car, right, you cannot just give one acceleration. See, this is a very common mistake a lot of people will make. They're just saying that speed is increasing at the rate of 2 meters per second square. So that is your acceleration. Well, that's not it. That would have been your acceleration when it was moving in a single direction, but it is moving in a circular direction. So there's one additional acceleration. And if they're asking acceleration of the car, you have to find out the resultant acceleration of that additional centripetal and this 2 meters per second square to give the total answer. You cannot just say that increasing of speed is the only acceleration. There's an additional acceleration because of circular motion, which you have to take into consideration. Okay, you know tangential acceleration is 2. And can you find out the centripetal acceleration? Centripetal acceleration is nothing but v square by r, right? If your object is moving with a uniform speed of, let's say, 30, then it would be 30 square upon r, right? V square by r is the velocity. Now your object is not really moving with a uniform speed. So at every point, your v is going to keep changing, your speed is keep going changing, and then your speed is changing, so your centripetal acceleration is also changing. Okay. When your speed is 40, it's going to be 40 square upon 500. When it's 50, it's going to be 50 square upon 500, and so on. But at this particular instant of time, when your speed is 30 meters per second, then your acceleration is going to be 30 square v square upon, v square upon r 500. Okay. So can you calculate v 30 square upon 500 to find out the tangential centripetal acceleration? 2 zeros will get cancelled. Okay. It's going to become 900 upon 500 basically. Answer, it's going to become 9 upon 5. 9 upon 5 is your centripetal acceleration. So your answer has to be under root of 9 upon 5 square. 9 upon 5 is nothing but your 1.8, right? See, they have given one option as 1.8 also, because they want to confuse you. You have tangential acceleration of 2, which is not the only answer. You have centripetal acceleration of 1.8, which is not the only answer. Either way, you can make a mistake. You have to take the resultant now. So it's going to be under root of 1.8 square plus 2 square. Okay, under root of 2 square plus 1.8 square. Okay, so once you calculate this, and I can do it here, it's basically under root of 4 plus 1.8 square so it's going to come out roughly equal to 2.7. Coming out as 2.69 or something. So this question requires a little bit of calculation. Not every question is going to be that straightforward for calculation. So here, once you do that simple, squaring and rooting, you will be able to find out the answer as 2.7. Okay. Let's move to the next question. What is the ratio of the average acceleration? Let me erase this all. What is the ratio of the average acceleration during the intervals OA and AB in the velocity time graph as shown below? So when you see the graph, I'm sure you know that your slope of velocity time graph, and slope of velocity time graph is what? It's nothing but dv upon dt, right? dv upon dt is nothing but your slope of the v versus t time graph. So obviously your slope of velocity time graph is going to be acceleration. So the ratio of the average acceleration during intervals OA and AB. OA is one time interval, AB is another time interval. So during this period, the acceleration is going to be slope of this. During this period, your acceleration is going to be slope of this. Correct? So you can find out the acceleration of this by taking perpendicular upon base, which is nothing but 40 meters per second upon this. Now, this length has not been given to you. So how do you really find a ratio of those accelerations? Okay, let's look into it. Can you say, can you look at these angles and can you apply a little bit of trigonometry and say that sine 30 from this triangle, this entire OCB triangle, sine 30 is going to be perpendicular upon hypotenuse and cos 30 is going to be base upon hypotenuse, because this will become base, right? Because we're talking about 30 degrees here. Now, what is cos 30? Cos 30 is under root 3 by 2. Okay. So under root 3 by 2 is equal to OC upon OB. Okay. And sine 30, perpendicular of sine 30 is 1 by 2, is going to be equal to, sine 30 is going to be equal to perpendicular upon hypotenuse, perpendicular BC upon OB. Correct? So now you have to find out the ratio of this slope and this slope, right? So ratio of this slope is going to be what? CA upon OA. CA upon OA. Okay, and you have to find out the ratio of this slope. This slope is again CA upon AB. AA, CA upon AB. Okay. So this entire thing, when you take, cancel CA is going to become AB upon OA. Okay. Now let's see. AB upon OA. Now, can you find out? Can you look at this? Let's say this is this. Okay, I think I'm sorry. I'll have let's look at it in another way. You have to you just have to find out the ratio of these accelerations, right? So you just have to find out the ratio of these slopes. Okay, so you have to find out this upon this. Can you look at these triangles and can you say that these are similar triangles? This triangle is similar to this. Why? Because a similarity. This angle is 30 degrees. This angle is 30 degrees. This angle is 90 degrees. This angle is 90 degrees. Why is this angle 30 degrees? Because this entire thing has to become 180 degrees, sum of angles of a triangle. So this 90, 60, 30. Okay. So now can you take a ratio? I mean, is it not going to be AB upon AB upon CA is equal to CA upon AB upon CA is equal to CA upon, I'm sorry, just give me 1 minute. Yeah. So when you do that, then you will be able to calculate. Okay, we are running out of time actually. I'm going to move ahead because we have another question to do. But once you do that and you calculate the ratio, you'll get the answer. Okay. I'm sorry. Just give me 1 minute. Okay. Your answer, anyways, I'll just tell you the answer. Your answer is going to be this 3. Okay. Your ratio of acceleration during the intervals OA and AB is going to be 1/3. Sorry. Okay. Okay. Huh. Force is given by force is equal to A plus BT square, where T is the time. The dimensions of A and B are, force is A plus BT square, T is the time, dimensions of A and B. So obviously, you know the dimensions of force, right? It's mlt minus 2 kg meters per second square, correct? This is M, this is L. Now, when you have sum of these two terms, this individual term also has to have a unit of mlt minus 2. This individual term also has to have a unit of mlt minus 2. Only then your force can have a dimension of mlt minus 2. So this thing is mlt minus 2, which means if A into T dimension is mlt minus 2, mlt minus 2. So what is going to be the dimension of A? You take T on the other side. Is it not going to become mlt minus 3? Yes, right? Similarly, if BT square is mlt minus 2, then you take T square on the other side. Is it not going to become mlt minus 4? Correct? So A will become mlt minus 3, B will become mlt minus 4. Your D is going to be your answer. This option is very, very close, but it's ml2t4. No, that's not the case. mlt minus 4, mlt minus 3. Okay, fairly easy question. You know the dimensions of force already. Each term individually has to have the same dimensions. Okay. We won't cover, let's say, assertion reasoning types already. My suggestion would be that my opinion would be, let's quickly cover one paragraph question, wherein this is on projectile motion. It's a series of 3 questions that is going to clear your concepts of projectile motion as a whole. Okay. So an airplane is moving horizontally with a speed of 720 kilometers per hour, drops a packet while flying at a height of this. So let's say an aeroplane is moving like this. The speed is 720. Okay. And then it is having at a height of 396.9. Okay. 396.9. Okay. So the time taken by the food packet to reach the ground is, the speed is this much, 720. And now, whenever you're talking about projectile motion or motion in two dimensions, you should always consider it as a combination of two motions. Okay. So combination of two motions. Okay. So you can think of this as one motion happening in horizontal direction and one motion happening in vertical direction. So let's look at vertical direction only for the moment. You have to think parallelly. You have to think those two motions parallelly. So let's look at the vertical motion. What is the speed in the vertical direction when the packet is dropped? It's zero. Why? Because horizontally the aeroplane is moving. So along with the aeroplane, the food packet is also moving horizontally. So at the time of dropping, its initial velocity in the vertical direction is zero. Its initial velocity in the horizontal direction is 720. Okay. Then after dropping, what is the acceleration in both the directions? Its acceleration in the downward direction is 9.8, right? Its acceleration in the horizontal direction is zero. Why? Because in horizontally it has just dropped and it's going to go constantly with a constant horizontal speed, right? There's no acceleration occurring in horizontal direction because there's no force occurring in horizontal direction. Vertically, there is an acceleration which is 9.8, which is g, because whenever a thing is and whenever an object is falling under gravity, its acceleration is the same. It's g, 9.8 meters per second square. So the time taken by the food package to reach the ground, horizontal, if you look at the vertical motion, your u is zero, u is equal to zero. How much distance does it have to cover to reach the ground? 396.9. So s is equal to 396.9. Okay. And a is equal to 9.8 meters per second square. So when you know u, s, and a, can you not find out time, t taken to reach the ground? There's one equation which relates everything. S is equal to ut plus half at square, wherein u is zero. So 396.9 is equal to half into g, 9.8 into t square. Okay. You can use that to calculate the value of t. Okay. Awesome. I'm not going to calculate it right now, but the question is fairly easy. This is going to become into 2 upon 9.8 g, and then in the end you'll have to take an under root. This number is in such a way that it will get cancelled and you'll finally get a decent answer out of these four. Now, whatever your time comes, t, whatever your time t comes, let's say it's x seconds, can you not use that time to find out the horizontal range? Because you already know that, this is the time for which it is basically in the air, and during that time it is also moving horizontally with a speed of 720 kilometers per hour. Okay, so 720 kilometers per hour, it's moving horizontally. You multiply that by the time, right? 720 into the time, whatever you get it, it's going to give you the distance covered horizontally during the time it took to reach the ground. Okay, the speed with which it strikes the ground. Again, very easy question. When it's moving, its u is zero in vertical direction. You know acceleration due to gravity is your 9.8, and you've already calculated time in the first part. So you do v is equal to u plus 80. U is zero, so v is equal to acceleration, or v is equal to 9.8 into time. Just when you multiply 9.8 into time, you'll get an answer which is going to give you the speed with which it strikes the ground. Okay. The answer for this question actually, I think, is none of these. So if you get an answer which is not one of these options, please don't be scared and just mark some answer for the sake of it. Whatever answer you get, only mark that. If it's none of these, it's none of these. Okay. This is it. We have covered this paragraph and we have also come to the end of our session. So thank you very much for joining. I just want to once again mention that Myadyapika is an online teaching platform that can really do wonders to your JEE and NEET preparation. And it has very, very good quality faculty that give personalized attention to all the kids that are enrolling with Myadyapika. So I would like to invite you all to join your competition exam journey, and I would also like to wish you all the very best. Thank you very much for joining.